Today, we're happy to present you with an overview of how modern CAD integrated CAM tools can be used to reduce programming time while improving data reuse and collaboration using a cool model you might be able to relate to. Putting on the webinar today, we have Tim Fulton, our CAM product manager. Tim has over 30 years of manufacturing expertise running and programming CNC equipment. And in his free time, Tim designs, programs, and manufactures off-road products using the tools we're about to show you. Also on the line, we have Daniel Lyon. Daniel's an experienced engineer with a ton of knowledge of manufacturing, programming CNC equipment, and fabrication. Daniel's constantly learning new tools and techniques our customers can leverage to push the boundaries of what's possible. So Daniel, you're going to kick us off today and give us a little bit of an agenda before we actually dive into the software?
Yeah, sure thing. Perfect. Thanks, Tim. The main kind of consensus that we're talking about during today's presentation is collaboration between different users. So whether they're using SOLIDWORKS CAM, the one that's included in SOLIDWORKS, or if they've got SOLIDWORKS CAM Professional. We're also going to be talking about streamlining workflows, how you can leverage existing programs in different ways, how you can teach the software your strategies and things like that. And also, as these machines, CNC machines, get more and more complex, looking at machine verification, so machine simulation and doing that sort of stuff. So we're going to show you a bit of programming in SOLIDWORKS CAM and CAMWorks. We'll talk about CAMWorks Virtual Machine and Eureka for G-code simulation. And then we'll also talk about a new tool called Shop Floor from CAMWorks that allows you to better communicate your actual programs to the shop floor. And also Predator, which does the actual CNC communication, sending your programs directly from PDM in this case. Actually, we're going to show you exactly how you can kind of go about doing that if you wanted to actually manage your CNC programs in a PDM environment. So with that, I'm going to kick it over to Tim. So this is Tim Fulton, not Tim Newton. We've got two Tims on the phone here. So I'm going to switch it over to Tim, and we're going to walk you through kind of a programming of a part file. You should be able to see Tim's truck right there. Tim?
I'm going to open up Op1, is what we talked about first earlier today. So the big thing we want to do is kind of collaborate a little bit, right? So when we're in a shop, you know, we have engineering, we have the shop floor, we have all these different people going on, and all their hands are touching a part. So the idea is, how can we talk about this and communicate with this? And those are the tools that we actually want to show off today. So our first thought, Daniel and I would kind of go through and discuss this part a little bit before I actually start programming it to make sure we're on the right page. So any questions, Daniel, about this part as we start getting into this thing?
I don't know. Maybe the threaded holes in there. Last time we got a part that looked like this, right in there. It didn't seem to break through. So maybe we want to check in on that and see if engineering needs to, if they drew the part right to start with. You know what those guys are like, don't you, Tim?
Oh, that never happens. What are you talking about? It's always right and perfect. So do you want me to let me go ahead and get started on this part and check in?
Yeah, you go ahead and get started. I'll start on Op2 looking at the 4 and 5 axis stuff. You get started on this, and I'll check with engineering to see what the situation is with those threaded holes and see if they're blind or supposed to be through. Okay?
Okay, perfect. Sounds good. So what I'm going to talk about today is how to do some programming in SOLIDWORKS CAM Professional. The reason we're running Professional today, SOLIDWORKS CAM Pro, is because we're going to run in assembly mode. So I'll get into that a little bit at the end of the presentation. We can kind of go from there. So basically, everything's set up inside here. So you have a taskbar. Everything's turned on. So the taskbar will look exactly the same if you were in standard. I have Pro turned on, of course, because I want to do in assembly mode. So you choose your parts, right? So you can come in here and I can select my parts. In an assembly, you have to tell it which part you actually want to run. So I need to select on this so the CAM software knows to machine this part and not the rest of the parts. So you would do that inside here. So to get started, you just choose your machines. You kind of go through, it pops up. These are your options. When you're in Pro, you have turning as well. You can go to your tool crib. You can select the tools you want to use. You can set them as priority. You can say, hey, every time we do this type of manifold or intake, we actually use these tools, and we can apply that information inside there. Post processors, I have a few loaded. I pulled these off of our website. So at the end, I'll show you guys how to get to these websites, where the website is, so you can actually run the post processor. So Just depends what kind of machine you want to run. You can go through and select that, and then you can get the code out of there. So these are no charge. They're actually on the Hawkridge site. Posting, what do I want to do inside here? Program numbers, different things. And then on the setup, I just don't want to do any indexing, right? Because this is a real super indexed part. But what I want to start with, I just want to start the first operation so I can load it into another set and then take off from there. So I can set that up. My stock manager, if I double click on that, I can go through. You have 4 different options here. You can choose a bounding box, and I can just change the sizes right here. I can go through a sketch, so I've had an actual sketch inside here. I can use an STL file to drive the stock. We'll get into that a little bit later. Or I can actually use a part. So if I want to draw a part, I can use it. You can see over here in the tree, I can just select my part. And now my part pops inside there. So it doesn't matter. I use the square block. It was just a good round size, 7 by 5 by 6. It can be a casting, a forging, anything you want. You can use it inside of a part. And then based off the material I want to run, I have a list here I can go through, whether 1018, 304, whatever the case may be. There's 2,200 different types of material inside here. You can pick whatever you want. These are just a few that I have loaded. Then from there, I need to set my coordinate, right? So I can tell the machine which way I'm going to machine from. So the good part is we override kind of how the engineering might draw it, right? So you might set it up differently in your CNC. You can see here the Z, the X, and the Y. It doesn't match exactly mine because I'm going to load this with the X running from left to right. So, and then I can choose anywhere on these dots that I want to set the post or set the thing up inside here to do the coordinate. So I'm going to do from there. And then what I'm going to do is run extract machinable features. So since I'm doing more of the 2.5 axis side, Daniel's going to focus on the higher end side with running the CAMWorks. I'm going to extract machinable features at this point. It's just going to analyze the model. So because I'm in an assembly, it's only going to choose what's pointing at the spindle at this point. If I wanted to turn the rest on, I would actually need to turn on either indexing or put multiple vices in here to show the actual spindle to the parts. So inside here, you can see I have a setup, I have a face feature, and I have my hole feature. So there's my quarter 20 tapped holes in all 4 corners. The reason those got picked up is because whoever designed this model used the hole wizard. So SOLIDWORKS CAM knew that, reading off a hole wizard what it would actually be. It didn't find everything. I still want to cut around the top of the part. So as I get into here, you can see I can go through and I can do feature manager. I have multiple setups, right? But this is the only setup that actually looked at the spindle. So what I want to do here is I want to right click and I want to insert a 2.5 axis feature because I want to cut around the top of this part right here. So as I pick on it, here's my different options: pockets, holes, slots, bosses, whatever I want to do, right? So I'm going to pick on an open pocket and I'm going to pick the edge of the part right here. And now that would be my open pocket. My in condition, how deep do I want to go? I can randomly throw a number in here. But if you keep hooking information to the model, if it ever goes back into engineering and you want to make a design change, it'll actually update the toolpath as well as it goes through here. So I'm going to rotate this, and I just want to choose a spot right here on the model that I can actually hook up to when I'm getting inside there. So and then this will allow me to make any changes as I go through the actual part itself. So you can see it's hooked it through. It's about a 1/2 inch deep right here. I have a strategy to rough and finish. I also want to take the island out, right? So I have this part inside here. Next is the island. I can do an auto detect or I can just pick the top of the island. Some people say they like the automatic side. Some people like the using it yourself. So that's what I'm showing a little bit of both here. So I can select that. And now I have my features to run this part. Next thing I want to do is generate an operation plan. And what it's going to do is going to analyze the model and figure out which tools and which things go inside there. So you can see I have a face feature, a center drill, a tap, a rougher, and then a contour mill. As I go across the top here, you can see everything starts becoming available, right? Simulation is not available because I haven't generated the toolpath yet. So I pick on generate toolpath. You can see I now have my toolpath wrapped around the outside of the part. I may not like exactly what it's giving me, and you never have to stick with what it does, right? So you have full control still. If I double click on the rougher, I can now go through and start making any changes I want to that rougher. So once again, it gives you a set of rules you can go through and start programming the part with, and then you can modify whatever you want. You can save what you want. So I go to my tool crib. Maybe I don't have the 3/4 inch tool. Maybe it's dull without being resharpened. I want to go with a 1/2 inch tool. All I have to do is pick select. and then I can choose to select, and it just chooses my corresponding holder with that. I can go to my feed rate. How fast do I want to go? Libraries based off what the tool library is set to. I can go to a tool specific, or I can actually go to operation, right? And I can just kind of throw in whatever part I want. I can say, hey, it's 2,500 RPM. It's going to do a lead in of 15, right? And I can start making those adjustments. I can go to roughing next, patterns, right? Pocket in, pocket out, zigzag, spiral. As I pick on this, the UI is very good. Well, UI is interface, right? User interface here. So as I pick on this, you can see the user interface change, and it kind of gives me an idea what's going on. I have an option for volume mill because I am in the pro level of SOLIDWORKS CAM. So I pick on that. It's going to ask me, it says, hey, well, based off this, you're going to need to change your feed rates, and let me help you. So when I pick on this now, it's going to open a parameter page, right, on what it's capable of doing based off what I chose on the machine. So a whole list in here, it shows aluminum because I'm already on aluminum, but if I was doing tool steel, alloys, carbon steel, cast iron, whatever the case may be, I just choose on that, right? The coding is a tool coded, uncoated, whatever the case may be here. And then the taper, right? 40 taper, 50 taper. Mine's a 40 taper machine. It's an end mill holder. Am I going to chuck it in a collet? As I change these things, the toolpath or the feed rates can change down here as well. So you can see I have a conservative setup and I have an aggressive setup. So if you're a little nervous, start conservative. And then as you drag it across here, you can see this is what's going to be selected. So if I hit the OK button, it's now going to readjust everything. It's going to change all my stuff. So if I hit preview, it'll now make the adjustments to that with my toolpath. It'll automatically adjust the step downs. It'll adjust the step allowance. All that stuff comes up inside here, and you can see it starts going inside. I have rapid planes, clearance planes. So there's a bunch of other options inside I'm not going to get into today. I just want to show you the basics that are set up inside. So I think that looks pretty good. Daniel, did you get back on the threads yet?
Yeah, they wanted the threads to be blind, so make sure that the boss depth is about 5/8, they told me.
Instead of the 1/2 inch?
Yeah, instead of the 1/2 inch that I think it's currently at, so back like the other parts.
All right,
And
no
can you throw some 3-axis in there as well, so I can pre-rough those intake ports?
Yeah, no problem.
Perfect. Awesome.
So right in here, right? The intake ports will you want me to do?
Yeah, right in those ports, yeah. Just put in a 3-axis rougher and finisher just to clean up that first section of the ports, and I'll do the rest on the 5-axis.
Okay. I can make that happen. So I'm guessing that's good now, right? Closed holes what they want?
Yeah, that's it, yeah.
Okay. So let me switch back over here. So I get a flag inside here, right? Because I hooked everything together, the model has changed. So if I say OK, what it's going to do is going to take all 25 automatic feature recognized features that I found, and it's going to reanalyze those and make sure things have been changed. So it's going to reanalyze the threaded holes. It's going to reanalyze the pocket that I have, or the boss I have down inside here now, based off of that. Then you can see over here starting to do its processing, right? So it's reworking the part, making sure this thing has changed. So it's giving me a flag. It says, hey, there's a set of threaded holes in here, and there was a set of other threaded holes. So if I pick on that, then I can just associate those. So I don't have to reprogram my threads in like I just say associate, and I can say replace or add if I want to keep the old ones in here and reanalyze what's there. I just want to replace those, hit OK, and now all my tap, once again, turns blue here. I can just hold my control key if I just want to work on those, and then I can actually generate the toolpath based off of that. So what Daniel asked me to do is put some 3-axis toolpath down inside here. So you got to remember, I'm still in SOLIDWORKS CAM Pro, right? It does have 3-axis toolpath. So as I get into here, it just does top-down machining. So I can pop back over here and I can right-click, and I can insert a multi-surface feature at this point. And there's a couple things I can do inside here. I'm just going to select all the surfaces. So it's going to do all displays, just selecting the whole model. And the good thing about doing this, it'll actually allow you, the tool, to keep gouging, right? It's not pick this, avoid that. You miss something and you gouge a part. So I have a multi-surface feature. I'm going to right-click on that. I'm going to generate an operation plan. And now I have the area clearance all set up inside there. But because I selected everything, I only really want to go down inside the cylinder area, right? So if I right-click, I can insert a new contain area. And then what I want to contain to, I can just choose it right inside here. I have a loop set. I'm going to pick on here. Goes into that loop. I got to choose that I want to do multiple. So I don't have to drag and drop and copy things. I see people doing that once in a while. I just hit OK here. And now I have that. And then the same for the Z level, right? I can set that all up inside here. Right click. Then I can go through and I can edit the definition and do the same. I can insert it under a void area, or because I'm inside the same file here, I can just take that same control, that contain area, control and drag it, and then drop it down inside there. Is that what you're looking for, Daniel?
Yeah, bingo. That's right on. That's exactly what I'm looking for.
So if I generate toolpath now on this one, I shall generate toolpath on both of them. Get going here. Generate toolpath. You can do it from the top. I can also do it from the bottom down here. It depends how you want to do it. Pick on here, generate some toolpath, and then my toolpath will start calculating and it'll stay inside the hole that's actually running. So you can see it's calculating. I can jump in, do a few different things here, whatever I want to do. It's just showing me the time. Area clearance took a little bit longer. So you can see it's calculating that, and then my Z level is now finished. So there's my area clearance, and then there's my Z level. So
perfect.
I can set that up, do whatever I want to do in there. So Daniel, is this going to work like this?
Maybe just cap it off about maybe an inch from that top surface if you can. We don't want to go too far on that. We'll let the 5-axis take the rest of the plots there from the opposite side. So.
Okay. So I'm going to right click, edit definition. You can also double click. So I'm going to pick inside here, and I'm going to go through and I can set what I want to do inside here, right? So I can set some limits up. So as I go through this information right inside here, there's limits. So I don't have to allow it to do the whole part, even though I selected the whole part. I can go through, do bottom allowance. I can do user defined, pick the very top edge right here, and then I can just tell it. Let me pick the edge, and then I can tell it what I want to do from there, right? So I can select it, and then I can tell it how deep I want to go. So I can go down the 1 inch that Daniel talked about, set that up. I hit OK. Now when I hit OK, it's just going to say, do you want to regenerate the toolpath? I can regenerate the toolpath at this point. So you have full control as you're actually running the actual model inside here. So there's my Z level. There's my area clearance to go to the bottom. I have all that information now set up. So now I just want to simulate it and make sure it's right. So I'll do simulate toolpath. And you can see my whole model there. So now I'll start to simulate. I can actually run the simulation going through there. You can adjust a few things inside here. I can control the speed. I can control whether I want to show the differences. I can cut the part in half. I can show tooling. And I can also do collision checking. Everything I want to do is set up inside this area right here. If I hit the go button, and then I'll take that toolpath and it'll finish that out. It's taking the rougher down, and you can see it's going down inside the cylinders now, making that, or the intake, I should say. And now that's all set up inside there. Okay?
Perfect.
At
so
this
that
point,
looks like it updated. I was just going to say, it looks like it updated the outside profile there. When you, since you adjusted the depth of that bus, it looks like it updated with it. Is that right?
Oh, yeah, that's funny. I actually forgot to check that. Yep, it got it. Cool. That works. So let me go ahead and save this now. I want to save this for the op2. I'm going to go through and I can just do a STL file. I can choose op1 and set up inside here. I can also choose whether it's inches and then the output coordinate, right? So you get the second op coordinate. This is kind of set up. You got to align everything as you're actually going through site here. So I'm going to pick on that and then get everything aligned and kind of go through there. I have op1 and I'm just going to hit the save button here. It should be good to go. Pick on this, hit save. Sure, I want to do that. Otherwise, I wouldn't have told you that. So I'm going to hit the checkbox, and now I have that set up inside there. Okay? Then I can actually send this out to the shop floor, get going. Go ahead, Daniel.
So do you want to jump into op2? Just want to open up, and will you help me do the 2D stuff on op2?
What, you got another meeting or something?
Yeah. I got to go out to the store and buy toilet paper.
You're always doing something. Okay, let me jump into here. Let me go to op2. Let me go to recently open. Let me grab op2, and I'll get this going. So let me hit the rebuild button. It looks like you've done some work or something on this.
Yeah. Yeah, I did one of the ports in there. You should see it. So it looks like it's giving you a warning there, right?
Yeah.
Yeah, that's just telling you that I've done the multi-axis. I started on one of the ports and then just sent it over to you so you can get going on it and do the 2D stuff. So if you click OK and switch to the cam tree, you should see it right in there. You should see my port roughing and then the surfaces that I use to go in and rough those out.
Okay. So it looks like the 5-axis came over, and it's just suppressed, so I can't really do anything with it at this point because you did it in CAMWorks, right?
Yeah. If you needed to make adjustments to the roughing, though, you can make your adjustments, but the 5-axis is locked out because you're in SOLIDWORKS CAM.
Okay, perfect. It's pretty cool the way they communicate back and forth like this. So let me go ahead. I can do the same thing through the tree, whatever I want to do. I'm just going to pull the features. So I'm going to extract machinable features out of it and just start analyzing the model. So what's happened now is it's set up as a 5-axis model. So the trunnion will actually index on this UMC 750. So now it can actually see everything that's actually set up inside there. Actually, I think I forgot to set that stock up that I just did. Let's take a look at that first. So let's do an area clearance, getting that set up inside here, doing all the roughing. That's about to finish up. You can see the percentage set up inside there. So the stock manager. So what I did is I used the piece right here. If I double click on the stock manager, then I can go to an STL file at this point, and then I can choose my STL file, and I can open that up.
Oh, looks like you forgot the coordinate system there, Tim.
How did that work?
So just click back on the box again.
Okay.
Go back in to open the STL file.
Right here?
Yep, right there.
Yep.
Click on the op, and then change the coordinate system down here at the bottom there to part coordinate, and you should be set.
Okay, part coordinate. It opened. Oh, gotcha. Okay. SolidWorks trick. See, I'm just a cam guy, man. All right. I'm going to hit the checkbox there. I got all that set up. And then there's all my new Toolpath setup. So I can go through and analyze this a little bit, right? So I got a face feature, right? I should probably just generate and extract one more time based off the new features. You can see my stock was kind of set up a little bit funky inside the basis setup. So the good thing is it just keeps reading through, right? It goes through one, goes through the next, resets the information up. So even though I made a mistake, right, and I chose the wrong stock, it's regenerating everything now as it goes through. And you can see my face features now change. It's based off the new stock that I use. So you don't have to be flawless through the part, right? As I go through, I program the part, I make a mistake, I can come back, I can do all the stuff I want to do inside there. So area clearance is updating there. I got all my information. There's my new face feature, my holes, my rectangular pocket, all my stuff, all my faces are set up now. So what I do have down here, though, is I have another setup, which came in from the bottom, right? Because I have the indexer all set up and turned on. So I don't need this. I'm just, because I did this already in op one, I'm just going to right-click on this and delete it. And now I should be good to go inside there. So now I can generate an operation plan. So it's just going to take all the information, update here, so I can take the blue stuff and redo it. I don't want to regenerate because Daniel already did some work inside there, right? And I don't want to mess up what he's done. Then I can generate the toolpath. Starts generating the toolpath and gets everything set up, and now I have my toolpath all set up to actually run that model.
Awesome. Cheers, Tim. If you just save that, I'll take over and I'll show people the 5-axis side of things.
Okay, let me hit the old save button here, and I'll hit save all.
So, Tim, do you see my screen now?
I don't see your screen yet. Let me see if I can switch it over to you.
I see it on my end, I think. So I think we're good. I can see it come up on our screen here. So,
there you
yeah,
go.
Cheers, Tim. Appreciate that. Cheers for doing all that effort. So all of our data, you'll see when I brought my file back in right in here, you'll see my multi-axis basically comes available again because I've got access to CAMWorks now. So this is all the work that Tim was doing. So we can save data to the assembly file. It's all going to be stored in the SOLIDWORKS file. So Same rules apply as if you're just drawing a fixture or doing whatever you need to do in SOLIDWORks. But what we're going to do in here is do some of the roughing again. So we're going to go and show you how basically we put in this process for putting in the port machining, and this is going to actually have the rougher and the finisher for 5-axis in here in one set of settings. We'll also, didn't we do one of these recently, Tim? Something like that?
Yeah, why are you going to re-rough it again? Why don't you just use the old data from the other part?
That's true. Let me see if I can find that guy. Actually, I think I can get it right here. So in this case, I've got some roughing from one side of the part here. I just stripped out the other operations and stuff like that. But I've got exactly the same roughing routine that I want to do on this file, but in my other file. So I want to try and take this data and push it over to the other file. So I've got roughing from both sides here. It's all set up. It's doing the 3/4 first from one side, the 3/4 from the opposite side, and switching to a quarter and using my rest machining in there. So we're not wasting machine time cleaning out little details and stuff like that, and then bouncing back and forth. So it's doing the indexing between these setups right here. But I want to take this data and push it over so I don't have to redo all that work again. So I'm just going to export this program out of this particular file, and you can choose to export and import through this tool here. Export this program out. You get to create a PRT CAM file if you're working in a part file, or an ASM CAM file if you're working in assembly like I am. Just save it over to this one right here. So this is pushing my data out, work offsets, setups, features, and then all I'm going to do is come over to my second op over here. I want to pull that data in. So we just use that same process that we just used, import. I want to merge it with this data. I don't want to lose all of Tim's hard work. I want to come in here and just merge the data together. So I'm just going to import that data right inside of this particular file. Now, since we're using rest machining, I might need to do a little bit of updates and things like that to the operations, but we'll cancel that rebuild for now. But you'll see it just pulled that data right into this particular file. But we want to do some sorting. We want to add a couple of other features and things like that into the model. So let's go ahead and do that stuff. So this is where we put in our surfaces up here. So we're going to go in and put in the other surface, and I'll walk you through how I was doing that whilst Tim was just working on the op1 there. Now in this particular case, we've got different ways of selecting surfaces. We can use either individual selections. We can just select everything in the screen if we want to. That's great for roughing things out. If you're doing some 5-axis finishing and things like that, you might want a little bit more control over which surfaces that you machine. So we're just going to go through here. And a great tip that I love to use is I have surfaces in SOLIDWORks. So one of the benefits of being inside of the SOLIDWORks interface is I've got access to all of the CAD tools that I need. So in here, what we've got is we've got a couple of surface bodies that we've used some of the surfacing tools in here to go and create a copy of this geometry. So I'm not suppressing any of the features. Tim, you know how annoyed those engineers get when you start changing all of their models and suppressing features, right? They really don't like us messing with it. They love to fill out everything, and then we love to take it off. But this allows me to go in and create a copy of the geometry, so you can just see the kind of outline there. We've just taken a surface model of it. It means that we don't have to suppress features, but then I can manipulate that surface and use things like a surface untrim. So you can see some of the ones down here, surface untrim on the surface toolbars, great for cleaning out those surfaces, cleaning them up. So we're going to use that to the surfaces, and just clicking on the surface itself means I just go in and select all those faces in the tree here. I don't have to mess around clicking on every single little face. That gets sure boring. I hated that when I used to do those little polylines and I had to click every single little line. Hated it. So I'm just selecting the surfaces here in one click. But rather than having to go and maybe import the data from a different file, I can also teach my database my strategies. So Tim was using some strategies in his database in 2.5 axis. Those can all be shared on the network location, so everyone's got access to the same data. But in here, I've got a port roughing and a 5-axis finishing operation here. So this is going to create the area clearance and the multi-axis mill that you saw. Basically what it means that I get is the ability to kind of go in and create these features and just tell it how I want to machine it. So in this case, we also want to go in and rough around the outside. So I'm thinking in this case, we use the outside surface here. So we've got a surface like this here that I'm using that sort of shape. That allows me to clean up the surfaces that I'm programming. It gets rid of all the weird little tilts and stuff like that I have caused by these little bosses sticking out and this sort of thing. Simplifies the surface, just using a boundary surface this is. And I've got another strategy for roughing the outside that just generates a multi-axis mill. So if you're doing a lot of similar types of parts, or even if you're doing a lot of similar types of programming, those strategies can really, really help you out. And in this case, we can go and generate the operations. I'm not going to lose any of the stuff that we've already done. I don't want to hit regenerate. I'm just going to hit update. And that's just going to generate the operations for me. So I've got that area clearance, the multi-axis mill for finishing the port, and then the stuff for doing the outside as well. But this tree looks a little ridiculous right now. I'm doing so many different tool changes. I'm bouncing between roughing in 3-axis, 5-axis simultaneous, then doing face mills. I just want to sort the entire tree out. I don't think the boss would be pretty happy if I'm sat there doing all these tool changes, right, Tim? So,
yeah, I'll be screaming at us, asking why the part takes an extra hour.
Yeah, so let's go ahead and just sort these operations out. So in this case, I'm selecting right at the top of the tree up here, rather than on an individual setup. I can do it at an individual setup if I just wanted to focus it down at that level. I can sort the operations, and it's only going to look at this one setup in the tree. That's one side of the part, basically. But in this case, we want to basically order these so that we've got everything done. So all the face mills are done first. Then we've got all of our roughers and finishers. And it wants to use as little tool changes as possible, but follow a certain order that we want in here. So I'm going to do the face mills first, drag and drop the area clearance up next. Then I'm going to do the multi-axis, actually, do the ports and stuff like that. Then I'll do some of the little slots and things like that on the side that Tim was doing there earlier. And then we'll do some of the center drills, countersinks, taps, and those types of things, the finishing stuff. And then we can sort by tool. And I can reverse this if I needed to. I could go in and actually set the tool as the priority first. But in this case, we're just going to choose this here. Hit apply, and it's one button to go through and reorder the entire tree. So it basically means that now my rest machining is all going to update, makes sense. So my face mill's coming in, taking off that whole chunk of material here, even though it's angled at whatever angle some engineer decides to align this up at, it's updating to the stock. We've got our face mill on the sides over here for cleaning those up. And the beauty about assembly mode is you can actually use it to kind of visualize where all your fixtures are and things like that. And we do that using this this fixtures tab. So right where you'd normally go in and set your work offsets and your origin points and things like that, right in here, we can see all of our indexing angles that we're calculating. So we know that that's basically one of these two solutions. And these are working to the limits that we've got set up in our Horst UMC 750 up here. If I change one of those so it only goes clockwise or it only goes counterclockwise, then I'll only get different results filtered out basically on the ones which are applicable to that particular direction. But in here, what we're doing is we're using the fixtures. So I want to be able to see those fixtures in the simulation. So I don't want the trunnion in here. I just want to window select all of this guy. Now I've got an intake piece right here. That's actually my fixture. So this is the same name as the part file that I originally created. This is the name of this intake. But I've got a different configuration in SOLIDWORKS just to build a fixture plate just right up for this. So it's not going to avoid this. It's actually ignoring the fact that I window selected over this because it knows that this is in the part manager up here as the one to avoid. So it's super simple to go and add those in there. So we've got our face mills. We've got our rougher for our ports here. Let's get that rougher for our other port generating there, whilst we're talking about some of this other stuff. And then we've got our roughers as well. So these are the ones that we imported down here, these set from the long version of this file. So we've got our roughing right here. We've got our other roughing right here. We might want to go and update the rest machining. So in this case, we want to turn on and make sure that the rest machining is actually factoring in all of this face milling up at the top up here, so that we're not actually wasting time cutting air either. So tool changes is one thing, but cutting air is another pet hate of the boss. So we're going to just basically factor in the rest machining for all of these, and we're just basically double clicking on them and updating it. I don't have to go in and change all the settings. These were all set exactly with the same tools that we were using before, same operations, same parameters. Basically, they're just updating the rest machining to this particular stock, which is that STL file that Tim saved out earlier. So we can go through that process, update the roughing, just turning on the rest machining here. And you've got some controls about how much material is left, depending on the different pattern types and things like that you use. You can come in here and control how much material that it thinks there is left. If you're getting too much code, you've got different options in there. And I'm just going to go and cancel the regenerate, just so that I don't just waste time waiting for one to generate and kick in. I just like to just set them all up and just get those 4 generating, and then we'll look at some of the 5-axis stuff as well whilst they're calculating. So we'll go through and set those.
I always actually generate each one. I like the idea of waiting.
Yeah, I love that little. Yes, it's multi-threaded. It comes in with a little process manager box. As you'll see right here, if we start generating these guys again, the port should be updated. That's not a problem. But as soon as we're generating here, it is multi-threaded in the software. You'll see that there's different processes actually calculating at the same time right here when it comes in. And we can change the number of processes that we want it to follow just by changing this number right here. So if I had 20 different roughing operations, if we were going really nuts on working our roughing tool down to a really small size, you could crank this up to, say, 10 processes, and it will hit the first 10, queue the next 10 up, and then just as one disappears, it bumps it up and keeps bumping up there. So just keeps it nice and clean. As far as the actual 5-axis stuff goes, whilst that's generating over here, I can continue actually just getting the setup done for the 5-axis. So we can go through here. We can tell it the surfaces to go and machine from. I just give it a second here just to kick in.
You know, you're always in a hurry, Daniel. Always clicking something.
Usually it's Amazon web store to buy something. The wife hates me for it. Some other cool, some 10 mil socket that I keep losing in the shop. So in this case, we're just going to blend the surfaces between this top edge up here and the bottom surface down here. So we're still using the strategy. So even if I don't remember that one little checkbox that's buried way down in these menus, CAMWorks has got my back because I can basically tell it to remember all of those settings. So all I have to do is go and tell it the surfaces to go and blend between. And in this case, we've got all of our control, and that's the beautiful thing about the multi-axis operation here. You've got all of the control over the different entry methods, how it links between the zig and the zag portions of any toolpath and things like that. Do you want it to stay down or lift up? You got lots of finishing options on your finish tab as well. Do you want to use adaptive step overs even in multi-axis? And on the axis control here, we've got access to all of our different tilting mechanisms. So essentially, if we wanted, in this case, we're using just the surface normal of the part, as you can see in the image there. Again, the images are fantastic at explaining what that's going to do. And it even tells me if I set this to 90 degrees right here, I'm cutting with the side of the tool. So I'm swath milling this basically all the way down the port. But obviously at some points I'm going to get into trouble when I get way deep into those ports down here. So what we're using is we're actually using the gouge check based on those same surfaces that we selected to drive the toolpath. We're using the gouge check and then basically telling it to check for the flute, the non-cutting portion, and the shank of the tools, as well as the holder, and then automatically tilt. I don't need to set any angles or anything else up. It's just going to go through and calculate that stuff automatically. So in here, we can go through. That's our first operation done for our multi-axis right there. Probably just set that one up, so I don't need to generate that one right now. And then we can do the outside surface. So like I said, we're using strategies here to save ourselves some time. You can probably see some of the rest machining trying to calculate these as I'm going through. So it's still updating that last area clearance by the looks of it. That's why it's blue. But I'm still being productive. In this one, we're using the same sets of surfaces, so we just have to tell it this is the top surface that we want to blend between, and this is the bottom surface that we want to blend between. In this case, we're actually using a slightly different strategy. In this case, we're actually going perpendicular to the surface. So we're just going to try and keep the tool pointed to sort of the middle, basically perpendicular to that surface that we actually built, so we don't get all of the weird tilts caused by these little lugs. But what I'm going to do in this case is a nice little trick. We're going to go through and use the gouge checking here to actually tell it to go and gouge check the main piece. Obviously, if I cut the toolpath as it is right now, it's going to basically cut to the surface, which is going to cut these lugs clean off. But in this case, I'm using that same technique that I mentioned earlier, selecting the solid model. So this is now going to gouge check all of these surfaces. And then our strategy here is set up, so rather than having to click 344 times, something like that, I'm just clicking once on my model. So in here, we're telling it to use the gouge check to go in and pull the toolpath out from that surface wherever it needs to occur. And then this is where we can control that. So rather than tilting the tool this way, we're using the gouge check and actually forcing it to gouge and pulling the tool out along the tool axis, basically. So we can get those kicked in and basically get them being generated, and then we've got our program done. Our order is nice and clean, and everything else is ready to go. So we reuse existing data. We save strategies for our database. We're using some of the rest machining to save time in terms of not roughing it out there. But we want to basically try and get this on the machine as soon as possible. Tim, what do you need for setup?
Just give me the setup sheets. If you can just print those off, I can take those out to the shop floor, and then I can get my guys go ahead and start putting tools, get the order set up, get everything dialed in on the tool list.
Did you say print?
Well, yeah, print the setup sheet so I can take them out there and I can give them to the guys.
Tim, we got to save the trees. You not seeing the toilet paper shortage? Got to save the trees.
Yeah,
We're going paperless, Tim. So we can.
I'm old or something?
No, I'm just gonna say you need a toilet paper coming up soon, probably.
All right.
So in here,
what you're telling me then.
So we're gonna actually generate the machine simulation. Actually, we'll kick right into the shop floor document. So this is where we're going to use shop floor. You'd normally output this from right up here from publishing shop floor, but since it's calculating, let's just go ahead and get that opened up. So shop floor essentially is a product that was released in August last year that allows you to communicate better to the guys on the shop floor. Hence, the easiest way to explain it is basically think of e-drawings, but for CAM tools. So what we've got in here is essentially the whole model with all of the toolpath. So anyone, if there's any issue or any question about what's going on in here, they can go and see and look at the actual operation. So say, for instance, I'm actually doing some probing in 2020. They added probing in here. So I actually put some operations in here for probing these bores. Maybe they need to know what size that particular bore is or what it's supposed to be. They can do measurements in here. So you can even go and say, okay, what is the diameter of that bore based on this edge? So I can give them control over what that is. Obviously, there's actually a possibility to output MBD, model-based definition data, into this as well. So if you've got dimensions or tolerances on your 3D file, those can actually transfer across over here. But not only that, you have the operations, you also have the tools. So what's fantastic is I can come in here and give this to an operator. He can go and look at every single tool, what tool length it is, what fluid it's supposed to be, what the holder's supposed to be, and everything else, and basically use it to go and set up the machine. You've got access to, like I say, you've also got access to the simulation. So the same simulation that we saw in CAMWorks, you can come in here, and SOLIDWORKS CAM, you can come in here, simulate the program, and see exactly what it's trying to do. If there's any question about it, you've got a clear picture of what's happening on the screen. You don't have to walk over and bug the actual programmer or take him away from doing his job. You can just open it up and look at the actual shop floor document.
So I don't need setup sheets printed off anymore.
No. If you wanted the setup sheets, you've got them right in here too. So the setup sheets, you can output a setup sheet with this, with all of your tool information if you wanted it to. So this would be this normal setup sheet that you'd go into your software and basically right-click up here at the top and go generate setup sheets down here. So
Wow.
This is the same setup sheet that you'd be generating from there, just using the templates, but it's right inside of this shop floor document. I've also got access to the code. So the code is right here, and this is opening in CAMWorks NC Editor. I can see if there's any tool changes. I can basically get some statistics from the Toolpath. Even without any of the shop floor document, you can go in here and actually calculate what the max and min Z depth is. So check your flutes and you should be good to go, and make sure that I've not done something stupid there.
The problem is, Daniel, is my guys on the shop floor, they don't have CAMWorks or SOLIDWORKS out there. How are they going to open this?
Oh, they don't need CAMWorks. They just need a license to shop floor. So we can produce it. They can just go in and open this shop floor document up and get access to all of this data without having to go and bug or take that operator away from the machine. So they can do
my guys
measurements.
spend so much time testing tools because they don't know really where they're going to go. I've just been using these setup sheets out there. So it takes forever, green button, red button, right over and over trying to test. But now they can see what's going to happen before they even hit the green button. That's amazing. How long have we had this for? When did we buy this?
Just since August last year. So not too long ago, but it's a fantastic addition.
And you're just now telling me about it. I like it. Thanks.
Yeah, well, communication travels slowly, doesn't it, in the paper world?
Evidently.
So in here you can even see the offset. So if the operator was setting up wrong, you can see what offset it's supposed to be, the location of it, and things like that. Obviously on the UMC, we could have been putting it up here and using dynamic work offsets and stuff like that. Maybe we chose not to because we're doing a production run and saving setup time and things like that. So there's our shop floor. And then also what we've got right here is we can output this. Now that we've got our code, we can actually output this to Eureka, our machine simulation tool. So we'd normally actually go through the process of posting this out. And just for the sake of time here, we're getting close on end. You can go through your process, post out that code right here, and it's going to kick the machine simulation in right here. I've actually got one that we saved out earlier, just so we should be able to see it. Let me guess, it's just hiding behind all of these other menus here. And this is with either CAMWorks Virtual Machine or Eureka. And basically, what this allows you to do is take your program, simulate it virtually based off of the actual G code itself. So you're not having to rely on what we call apt data, cutter location data. It's going to bring your program right up here on the screen. If needs be, you can also load the program into it in different versions. So I can tell it to go and say, take op2 text, for example, and go and load that program in here. I can detect collisions beforehand. I can make sure that the machine's tilting the right way and things like that. But I've got basically control over it. It looks like my program didn't actually come in here because I must have overwritten it. But this allows you to detect collisions and things like that with it and see what the situation is. So if I actually pushed it from here, I'll just simulate the first lines or something like that. It will kick all the tools over, all of your work offsets. You can move the whole toolpath around. You've got an idea of what G codes are active and things like that. As these machines get more and more complicated, machine simulation becomes more and more imperative to make sure that you're actually staying effective. So this loads the program up and everything else. So, but let's say we get the code over to your CNC, Tim, and let's get going with it, right? Shall we?
Yeah, you're gonna get me in trouble, man. I got to get going before lunch starts.
For sure. So right inside of here, we just got a vault system in PDM. So I'm in SOLIDWORKS PDM right now. We've got a vault system set up so we can track all of our data right here and track things like our CNC programs. And if I want to send this to the machine, I don't want to sit there walking code back and coming back and if there's an error with it or the USB didn't register it or whatever, I can just right click right here, send to CNC, and then basically send it to my UMC 750. So I can actually use Predator DNC to communicate to the CNCs right from PDM. So in here, I've got my machines listed right here. So I can click on my machine here. It's ready to receive the code. I can check on all that. But I can actually go to my program right here and say op1, send to CNC, Haas, UMC 750. So that is actually going to read the data into my machine program and push it right over here, basically. So it's going to go in. You can see it reading the data into my programs. Looks like I probably sent it to the wrong one, but this is actually sending that code straight to the CNC. So it'll be ready right out there for you, Tim.
Perfect. Well, guys got it all set up already. Thanks to your new invention of paperless. We're good to go.
Perfect. So that's the end of the main demonstration part. Do you want to take over, Tim? Do you want to just keep me on my screen? And
Sure. So just to kind of go through all this, just to show what we've done today, right? So we took a part out of SolidWorks, and then we programmed it using two different programs, right? SolidWorks CAM and CAMWorks. So we wanted to show the integration between both. You can have one person using the SolidWorks CAM, whether it's standard or pro, doesn't matter. And then if you needed to get into the 5-axis or anything above what SolidWorks CAM Professional can do, you can utilize the CAMWorks. And you saw that Daniel started programming in CAMWorks first, and then I was still able to open that same toolpath up in SolidWorks CAM. They are the same package running in the background, and that's the beauty of it. And then the second thing you saw, we ran it through Eureka, right? We pulled up the G code, we were going to do the simulator, and then show how that worked, and then we pushed it through the Predator out to the shop floor, and it was waiting on the controller when I walked out there, and I was able to get it going right away. Next. So inside here, I want to give you kind of a breakdown. So SolidWorks CAM, when you're on subscription, right, everything in green is already included. So everybody on this phone who has SolidWorks already has access to everything in the green section on the left-hand side right there. So that means you can do a single part. You can do the 3D stuff I did. You can do the Z level, start at the top and work your way all the way down. What we showed today was SolidWorks CAM Professional because we wanted to run it in an assembly. We wanted to run it on the UMC 750. So touch base on the assembly machining, touch base on indexing right there on the right, and then we went down to the volume mill, and then Daniel touched on probing a little bit to show that how that actually works. And then from there, we went into the actual CAMWorks side, where Daniel went into the Mill Pro section to get everything going inside there. So you can see they just kind of share all the way across the board, right? And that was the biggest thing we wanted to show you guys today, is when you're programming, it doesn't matter if one person's working on one thing, they're working on another. The reason that we didn't really go into detail, the reason we showed it in assembly mode is because if we were running PDM, we could both have the model out, work on it at the same time. Because it's read-only, we're not going to mess up the model. We're just going to go through and give you guys a toolpath based off, and we're going to check it back into PDM when we're all done, and everything utilizes the same part, toolpath, everything is done the same exactly from there. Next. You're all just kidding. So a little bit about Eureka. We just took a picture of what we did there. You guys did not see the G code come up on the side because what Daniel did is he just pushed the go button and we kind of stopped it based off the time we want to wrap this up here pretty quickly. So the code comes in, the machine turns, it moves, it does everything else. So there's a couple things in Eureka. You can, if you run it through CAMWorks, you have an option to run the CL data only. So you can not look at G code, or you can step into the Eureka side and you can see all the G code from there. So you have a couple different options. CL data with just a toolpath that's on the model, or the G code at that point. Next slide. So shop floor, we introduced that today, so you guys can start going paperless if you want. The idea is to eliminate all the setup time on the shop floor. You have people out there, they touch all the tools off, they go through, they don't know where it's going, they've never seen the CAM program before, they run it in a flat simulation. If you're lucky, you have a 3D simulation on your machine. This actually shows everything. It shows the tools, it shows the setup sheet, it shows the coordinates where everything is going. You do not need a set of CAMWorks to make this a product of CAMWorks to make this work. All you need is the shop floor, right? So you can plug this into any computer on the shop floor, and then they can just open this up, and now they have a virtual set of setup sheets. Next one. So just a communication breakdown, right? A little bit about Predator. You know, it has an editor we can send back and forth. We can DNC. It runs a PDM of its own, and we also locked ours into PDM with the little work that Daniel set up on the back side. We can collect the machine data off the machine. So if you're going through and you want to know how fast the part really runs, was it in setup, was it in teardown, anything like that, we can collect all that data, tool tracking, the little touch HMI along the way as well. Next one, Daniel. So here's some of our services, right? We build our own post processors here. You're more than welcome to go to our website, download all of our free post processors. If you go in there, you'll see a list of how the tools are set up, what G code is produced. There's samples in there. Everything is inside those post processors for you to utilize and then use on your actual machine. We also do custom posts. So if you said, I don't want to edit this, I want to do probing, I want to output a tool list at the top, customize safety lines. Really, we just want to be hassle-free, right? We want to be able to pick on the part, pick on the code, and just run it. So that way you're not moving code around. You miss one little decimal point, all of a sudden you're putting the tool down into the actual table. We want to avoid all that. So Predator is just the way we communicate, and then the virtual machine simulator, you know, checks for crashes, things like that.